here. It's got a hole in there. Right? So, is it a continuous function?
No.
Not the way it is. Is this discontinuity removable? Well, let's see. How? What do we do? How? But like how? Mathematically. Yeah, Henry. Factor. Tell me. Give me factors, dude.
X plus 1 times x.
So you can see that by canceling this, you've removed the discontinuity because the graph then looks like a straight line equation, isn't it? Fx equals x plus 1, which is a straight line. So you can redefine this function as fx equals x plus 1 everywhere except x equals 1. And at x equals 1, you will define the function as equal to 2, which is this number here. That's 2. Right? So that's what removable discontinuity means. You can redefine the function and make it continuous. So you do it by factoring and canceling things out. That's the way you remove a discontinuity. Guys, with me on this? Yeah? Yeah. Oh, this part here? Let me rewrite that. So what I'm saying is that this function's got a removable discontinuity, and it can be redefined, right? Because that's what the book tells you. If you read at the top of page 71, discontinuities fall into two categories, removable and non-removable. A discontinuity at C is called removable if f can be made continuous by appropriately defining or redefining f. Okay, so this is what we are doing, redefining it. So here's your function as it was. By factoring, it becomes this, which is your straight line. For all x except x equals 1. But when x is equal to 1, you will redefine it as equal to 2. The function is equal to 2. This is x equals 1. Comes from here, right? This one applies to the x, right? Right? It's f of x. That means x is 1.
Why is it everything except that? Because even at x equals 1, it equals 2, and that's what you're saying except there.
Good point. I guess what I'm trying to say is that you cannot put 1 in this equation.
Okay.
Cannot put 1 in that equation.
But you can
Put it in the other one. Yeah. Yeah. So, yeah, if you want to leave it like this, you want to take that out? Sure.
We would need to write.
Then there are no exceptions, because this is true for all x. Right? Exactly. Okay. All right. So the thing you want to really take away from this is to remove it, you go to factor and cancel. Okay? So everybody with me on that? Okay. Jonathan, you're here. Okay. These notes, believe it or not, are straight out of pre-calc. Straight out of pre-calc. Okay? So we're talking about one-sided limits. So far we've been talking about two-sided limits. Okay, so this is called a two-sided limit. Okay, and I'll explain to you the difference between that and a one-sided limit in a minute. Okay. So could you answer that question with the graph that's shown? So the graph that's shown is this. That's the graph. Okay? It's called a step function. It's called a step function. Can you answer that question? What is the limit as x goes towards 0 of f of x? Yes. Sorry?
I think it's D&E.
It's D&E. Does not exist. Why, Stephanie? Why is it D&E? That's right. They're approaching two different numbers. Coming from the left, what number is it approaching?
Minus 2.
-2. Coming from the right?
4.
+4. Everybody with me on that? So the two-sided limit does not exist. But you guys got this down? Can I get the next slide up?
Why do they call it two sides? Because there's
Because you're coming from both sides. All right, you're coming from the right and you're coming from the left. Okay. Here is a one-sided limit. Here's the notation for a one-sided limit, right there at the bottom. Sorry? Did I seriously? Go back, take a look at chapter 11 videos and see.
You taught us eventually, but like it was a level of 2.5.
Oh, could be. Yeah, I might have forgotten to do that. So the notation is slightly different, okay? And you're playing opticians games here. Do you like this or do you like that? Are you playing opticians game? Kind of doing some physics experiments here. Oh, come on, man. Physics is good. It's fun. Oh. It's a lot of work. I mean, it's a lot of work, but it's all lab work, though, right? Because I think I can barely keep you in my class here, man. Are you taking notes? Did you get this down? Oh, so you...
You really hate all your students that go into business.
Oh, man, I got to go off record here.
It's fine, but
What was that?
if they do explain that it's fine, but
Yeah, but I mean, they don't want to be regulated. Even after that mess, they refuse to be regulated. Okay? I mean, come on. You know, you guys need to get your act together, you know. Come in Kramali's class, he'll set you straight. Okay, so one-sided limit. Okay, one-sided limit. So the difference is this notation here. What do you see strange there? The plus sign there, and here, a minus sign. So a plus sign means that you're going to come from the right of 0. Little bit more than 0. Yeah, don't just think positive because this could have been 2 plus. You'll see an example in a minute that it's going to be different. Okay, so don't think positive, negative. Think of coming from the left or the right. Okay, so 0 plus means you're going to be coming from a little bit more than 0. So you'd be going along this way here. And if you're going along this way here, what's the function approaching? Right there. Okay, and if you go from the other side, little less than 0, meaning coming from the left of 0, you are approaching what number? -2. -2. Okay?